Yeah. Hi. Welcome to the live session of Edubot. Okay. Let me start with the business problem here. Okay. So the traditional learning methods often fails to engage the students effectively. So this leads to reduce the interest, lack of personalized learning, and difficulty in understanding the complex topics. Okay. The schools require an interactive AI-driven educational solutions to support students with instant answers. So, subject explanation and adaptive learning experience while ensuring that response should remain within the provided syllabus. So, so this is our business problem. So, what does it means? So, school students are often failing to engage the with curriculum activities. So, because of the lack of personalized learnings and difficulty in understanding complex topics. Okay, so that was the reason our schools or our educational system requires that AI-driven educational solutions, that is like chatbot, okay, to get the instant answer and the subject explanation and the adaptive learning experience. Okay, so whatever the questions the student will ask, it should be response in the concise manner and a simple manner for the understanding of the students. Okay, so this was all about the business problem. Okay, so what's our objective here? To maximize the student engagement and learning efficiency. Okay, so and what is the next constraints? We have the maximize the off-topic response by restricting the chatbot to syllabus-based queries. So what does this constraint means? So we have to minimize the off-topic response. So here, what are the off-topic response? So whatever the topic apart from the syllabus or the school syllabus. Okay. For example, if the student wants to ask anything related to the cricket or the cinema or the any cars or the bikes, so it should restrict to the those topics. It has to only focus to the it has to focus only the syllabus based queries. Okay, that is our main constraints here. And when it comes to the business success criteria, increase the student engagement and the improvement in academic performance. So that is our the business criteria. And if you have the economic criteria, so that is the cost effective development and the maintenance within the school's budget. So we have to build a shortcut, so which is a cost effective and also within the school budget. Okay, should not cross the school budget. So this is overall understanding of the our business problem. Okay, so next we are moving to the what is RAG. Okay, so basically, we have to build this chatbot based on the RAG application or the RAG based approach, we can say. So what is the RAG here? So RAG is the, when it comes to the full form or the expansion, so that is a retrieval augmented generation. Okay, what is the RAG? RAG combines the document retrieval with a text generation. Okay, helps the model gives the factual and a grounded answers, reduces hallucination from the language models. Okay, so what are these three means? So combines the document retrieval with the text generation. So it will going to combine the document retrieval and as well as the text generation. So basically the document retrieval comes from the our knowledge database, that is maybe the textbook or the PDF or the e-PDF from the schools. Okay, when it comes to the text generation, it will come from the LLM models. Okay, so it's a combination of the both document retrieval and text generation, and helps in the model gives the factual and grounded answer. Okay, and also reduce the hallucination from the language models. So what is a hallucination from the language model means? For example, if I ask any question, so model will going to restrict to the that particular topic only. You should not hallucinate, should not imagine other than the topic. So it will going to help in the reducing the hallucination or the what you call the another word we can say the diversify the context. So you will going to reduce with the help of RAG. Okay. So how it works? So how the RAG will work? So if the user asks a question, relevant documents are reverted from the knowledge base. So if the user asks the questions, the relevant document are retrieved from the knowledge base. Okay, and the question plus document are fed into the generative models. So what are here the generative models? Our generative models are the our LLM models, basic like GPT or Gemini, Llama models. So these are all our the generative models. Okay, the model generates the final answer. So this is how the RAG work. So for example, if I repeat once, user asks a question. So basically, if the user asks what is the friction in the physics, okay, the relevant document are retrieved from the knowledge base. So here, what is the knowledge base? Knowledge base here, knowledge base is here our the PDF or the what you call the school notes or the school textbooks basically. Basically, the here knowledge base are the school textbooks. So it will going to retrieve the relevant documents from the knowledge base. Okay. So once the knowledge base is retrieved, the question plus documents are feed into the generative models. Okay. So next, now whatever the question we asked and the document which is retrieved are feed into the generative models to generate the concise response or the final answer. So once it's done, the model generates the final answer. So this will be the our final output. So which we can say on the user interface or the chatbot response. Okay. When it comes to the technical stacks, so what are the main technical stacks we can take it here in the RAG? So the retrievers. So basically the we call it retrievers. That's FIAS, MB25 or the Chroma. So they are the retrievers and the generators. So what are the generators here? So generators are the LLM models. So basically we have the GPT-4, T5, Gemini models. These are the generators. And we have the frameworks. So what are the frameworks? We have the framework LangChain and Llama Index. Now, so what are the frameworks? So frameworks are the way which can provide the chain of links. So if I take the LangChain as my framework, it has the provided chain starting from the creating the embedding, ending from the retrieval chain. So it all comes in a single chain. So it could be help in the production or implementing the application in the production. So that was the main useful use of the this LangChain and the Llama index. Okay. Next, we have the high level architecture. Okay, fine. So when it comes to the high level architecture, so we have the two phase. So here in the high level architecture, when it comes to the rank, we have two phase. That is the one is the training pipeline, the above one, and the below one, that is the inference pipeline. So let us see what is this training pipeline and the inference pipeline will do. Okay. So for example, if I take the data source, initially we have to come up with a data source, right? So if I take the data source as the online portal or the NCRT portal or the school book, so these are all my the data source. Okay. So which format we want? So basically these are all comes in the PDF format only, right? So these are all if I take the student school book or the NCRT portal website textbook. So basically those are all comes in the PDF format only. Okay. So this PDF will going to store in the Amazon S3 data storage. For the security reason, we have to use the Amazon S3 bucket for the data security purpose. Okay. So once it's done, once it's stored the in the Amazon S3 bucket, then the next task or the next task will be the text extraction. Okay. So whatever the PDF that the text contains a PDF that will go to extract in the text extraction process or the text extraction steps. Okay. So extracted text will go to pass to the text splitting or the chunking. Okay. So here the main part comes the text splitting or the text chunking. So why we do the chunking? Basically to feed the limited tokens to the LLMs. Okay. Basically the LLM models have some limitation of tokens. So to meet the requirements, to meet the requirement of those tokens limitation, so we are going to split the text into the token, into chunking part. Okay. So that is the text splitting or chunking will comes. Okay. So those text splitting or chunking will pass to the text vectorization or the text embeddings. Okay, so using embedding models. For example, if I'm using the GPT, if I'm using the Google embedding model, basically Google generative embeddings, so that will the helper or that is a model will going to create the text embeddings. Okay, so those embeddings will going to store in the vector database. Okay, so here we are going to get the database as the um, stored content. Okay, and we have another pipeline for the image extraction. Okay, if I the PDF contains any image, okay, so that's another part. So where we're going to extract the image and we will we will do some embeddings vectorization on that with the same embedding models. Okay, and we're going to store in the vector database. Okay, so right now we have the two vector database. One is for the text and another is for the image one. So again we are going to store both in the Amazon S3 bucket. So if it is the local, then we have to download them in from the inference model and we have to store it. If it is the in the cloud base, then we have to take the only the keys or the access key of the those database. Okay, so fine. So once mm, mm, fine. So once I will be stored in the database, once we get the database, then user comes here or the students comes here and he will ask the question with respect to the subject. Okay. If he has any question with respect to subject like physics, science, mathematics, biology, so we'll ask the question. Then that question will going to pass to the embedding model. Okay. So again, it will create the embedding model and that embeddings or the vectors will going to search in the this database. So here the comes the similarity search. So basically similarity search what it will do, it will going to pick the top k or the top k nearest models or sorry not models, the top nearest k context. Okay, for example, if I ask the what is photosynthesis from the biological standpoint of view, it will going to search what is photosynthesis in the database, in the vector database, as the top k nearest neighbor. So whatever the index we are from the query, those index will going to match it in the database and it will retrieve in the from the database. So those retrieved database will going to pass to the LLM models, and those LLM model will going to augment that. Okay, so if I get a simple one line answer, so our model will going to take the query and the context retrieved from the database and that will augment here. So that is the main concept of the RAG. So basically the RAG, retrieval augment generation, right? So LLM is supposed to augment the text and it will going to give the final response. So this is how the high level architecture of the RAG will work. Okay, fine. If you see the low level architecture, so what are the content, what are the functionality we are doing in the each and every steps. Okay, if we want to deep dive into the each functions or each steps. Okay, starting from the data collection as we discussed in the high level architecture, the data source, data collected from the websites, NCIT portal, from the schools in the form of PDF. Okay, so these are all the PDF elements. Okay, in the PDF elements, we have the text extraction by using the partition PDF from the unstructured library. Okay, so this is the models or the library we have used for the text extraction. Okay, and for the image extraction, we are using the PyMove PDF for the with the three respective character number and the name. Okay, this is how we are going to extract the image from the PDF. Okay, so then next comes the text chunking. Okay, in the text chunking, we are using the retrieval the recursive character text splitter from the LangChain text splitter with a split text into the 5000 chunk size with a overlap of 500. So this is how the chunking will happens in the using the recursive character text splitter. Okay, those chunk data will going to pass to the text embedding or the vector store. So using OpenAI embeddings from the OpenAI embeddings to create the embeddings and store it in the LangChain FIAS vector store. Okay, so this is how we are going to store the text extraction, text chunking, and the text embeddings. Okay, so next we have the image embedding. Okay, in the image embedding, so we are using the text embedding model quadrant clip VIB32 version from the fast embed, create the embedding for the image and the store it in a quadrant vector database. So here we are using the quadrant vector database by using the quadrant clip model VID B32 version. So this is a responsible to create the embedding for the image one. Okay, so next thing is the again we come the user here. Again the user will going to ask the question. That same question will going to pass to the embedding model or whatever the same embedding we have to take the OpenAI embedding models. So these embeddings will going to search similarity search in this vector database. So whatever the content we got from the this user, we're going to make the similarity search in the database. And using similarity search, we're going to find the using similarity search plus the relevant text and the images. Okay, so what we'll get, we'll get the relevant text, queries, and the images from the here. From here, we're going to get the queries from the user, and here we'll get the relevant image, and from here we're going to get the relevant text with respect to the question. Okay, that question will going to pass the relevant text to the LLM models for the augmentation. So here LLM models comes the GPT model. Okay, so this GPT model is responsible to make the answer more concise or the summarized manner to understand the school students. Okay, so this context or comes as the relevant text plus images. So whatever the questions asked by the student, through the similarity search, we will going to get the relevant text and the image as the final response. So this is how the low level architecture, basically the deep dive or the functionality within the RAG will going to work. Okay, so this is all about the Edubot realization. So this is how the RAG work behind the Edubot application. Okay, so when it comes to the 360, so what we offer the challenging real-time projects that pushes you to your limits and learning all phases of the project methodology and learning about the different tools used in the industry like Python, Power BI, and cloud platforms, and work on research paper that are used to publish in international journals, and access to various free tools that enhance your learning like mind maps and the LM machine learning architecture assistant and RO hub and the animated learnings. Okay, so for the more inquiry, please contact this number and follow us on Instagram, YouTube, and the LinkedIn. Thank you for this live session. Thank you for joining.